Okay, so the question is, the safety airbags in automobiles are inflated by nitrogen gas. The gas is generated by rapid decomposition of sodium azide to sodium and nitrogen gas. If an airbag has a volume of 36 liters and is to be filled with nitrogen gas at a pressure of 1.15 atmospheres and a temperature of 26 degrees Celsius, how many grams of sodium azide are needed? So the first thing we need to start with is a balanced equation, which is 2 moles of sodium azide will give us 2 moles of sodium and 3 moles of nitrogen gas. And now I like to decide what I'm going to do before I start doing anything. So what I'm going to do is I'm first going to find how many moles of nitrogen gas I have. Then from there I can figure out how many moles of sodium azide I'm going to need using the balanced equation. And then I'm going to be able to find out how many grams of sodium azide I'm going to get. Okay, so the ideal gas equation is PV equals nRT. And I like to go ahead and just add all of my, spoiler alert. Okay, I like to put all of my values in so that we have 1.15 atm pressure, 36 liters, we have R, and then we have the temperature, which is 26 degrees Celsius. But in this equation, we need to work in kelvins, so then I transferred it to 299 Kelvin. We need to change the equation a little bit so that we can be looking for moles. So it's N equals PV over RT. So once you have all this, then we can just plug our numbers right in. So then we have 1.15 times 36 liters over RT. Since these are multiplied, they can come in any order, and I like to switch them around, and I'll show you why. So we have 299 Kelvin, and then we're going to times that 0.0821 times these little stragglers on the end. And then we can cancel things out. And then we know for sure that we're going to be getting moles out of this equation. So then after you do that equation, you're going to get N equals 1.69 moles, and this is N2. Now, we know from this equation that there's a conversion factor of N2, so there's 3 moles of N2 for every 2 moles of sodium azide. So then that gives us 1.12 moles of sodium azide. Then with that information, we can figure out how many grams there are. So for every 1 gram, or for every 1 mole of sodium azide, there are 65.02 grams of sodium azide. And so then that gives us a total of 73.1 grams of sodium azide needed for this reaction.